Okay, so let me start. This one is a last topic of double integration application to find out the area of a region. Now, to get the area of a region, uh, the method that you learned in 12th, that also you can use it, because you know to get the area. Let I show you here. In 12th, you already seen, if the region is bounded by two different curves, say y equal to f1x and y is equal to f2x, and the region is in between them like this, and we have to find out the area between these two curves. Suppose this line is x is equal to a, and this is the point x is equal to b. So in 12th, yes, the area you can calculate by this formula. This is the area. First we find the area under the upper curve, so integration f1 dx from a to b minus integration a to b f2x dx, that is the area under the lower curve. So if you subtract the area of lower curve from the upper curve, then we get a required area here. But this same calculation can be converted in double integration formula also, and that is the way. First we a to b as the same limits, so that is the integral, and we get f1x minus f2x dx. Okay, because you observed that f1 and f2 just limits are same, so we can do that. Okay, so here uh, the same way, if you take a vertical strip, you'll observe the limits of y are f2 to f1, and this double integral is written as a to b, then that is f2x to f1x dy dx. So now onward, we are not going to use the formula of a single integration. Yes, we can do it by single integration also, but majority of the question we have to do it by double integration only. So we will start with the formula for area. That formula for area by double integration is dx dy or dy dx, okay, over that region. So double integration dx dy on the region gives us a area. Can anyone tell me what is the formula in a polar form? What will be the formula in polar form?
R dr d theta.
Correct, r dr d theta. So one simple formula that we should remember, double integral dx dy is the area, and if we want it in polar, just replace dx dy by r dr d theta. So that about the formula. Now let me come to the problem. The problem is we have to find the area between the parabolas. One is a y square equal to 4x, second is x square equal to 4ay. Yes, a few of the already completed it, that's a good. Okay, 149, whatever the limits you given, that is also correct. So let me see the curves first. So first let I draw this as x-axis and this one is y-axis here. Let I ask 148. Y
Yes, sir.
square equal to 4x represents which parabola?
Sir, right side,
Right
upper
side
parabola.
parabola. Correct. Y
Yes,
square indicates symmetry is about x-axis. This is y square equal to 4x. And second,
upper parabola.
upper parabola. Correct. Because x square indicates symmetry is about y-axis. So x square equal to 4ay. These are rough curves at all. So right now the region is in between them. So we have to find out the area of this region. What are the point of intersection? What are these point of intersection?
Sir, that 4a, 4a,
Okay,
upper.
good. Good. And that is a 0, 0.
Yes.
Okay, good, very good. Anyone have a doubt in getting this coordinate 4a comma 4a? To get these coordinates, you have to solve these two equations simultaneously if you are not getting. Okay, so these are the 2 points which satisfy both the curves there. Okay, now tell me the formula for area. 149.
Yes, sir.
Yes, what is the formula for area now?
So dx dy.
Okay, dx dy. If you want to keep the same order,
Yes,
what should be the position of a strip?
so same order, then we have to choose a horizontal strip.
Correct, very good. So tell me the limits of x then.
So the limits of x will be y square by 4a
Very good.
to y square by 4a to root 2 root ay.
Okay, or root 4ay. Both are same.
Yeah,
Good.
root
Okay, and the limit of y?
0 to 4a, sir.
Correct. Minimum value of y is a 0, maximum is a 4a, so that's 0 to 4a. So that is the end of, first of all,
So I'm done by vertical
vertical
strip, sir.
strip. No issue. Exactly same calculation you'll get and the same answer. You can do it by any of the strip, vertical or horizontal in this case. Okay.
Yes, sir.
So this about the limits. You can use a double integral dy dx also. Answer will come same. Now let me integrate this. So if you integrate first of all that with dx, integral of dx is a x, and if you put limit, that comes root 4ay minus y square upon 4a, and that about the integral of x, we left dy only. So that only the part we left now. So 180 180 is there, 180, no, so 150.
Yes, sir.
Integrate this now.
So 4ay root 4y 1 upon. So minus 1 upon 2 root y.
No, not correct. This root 4a is a constant as
Root
it
4a
is.
is constant, minus 1 upon 2 root y.
Y raised to half ka integration, not derivative.
Oh, sorry. Y to the power 3 by 2, 2 by 3, y to the power 3 by 2.
Correct. Now you are correct. And what about the integration of second term?
So y cube upon 3, 1 upon 4a, y cube upon 3.
Okay. Now just we have to simplify this, and that becomes our final answer. You'll observe the upper limit only will exist. So this is 4a raised to half. This is 4a raised to 3 by 2. 4a raised to half and 3 by 2 becomes 4a raised to 4 by 2, that is 4a square. So 2 by 3, 4a square. Okay. Now when you replace here 4a, so one of the 4a gets cancelled, again 4a square, so minus 4a square only, because one of the 4a gets cancelled, and that upon 3. So you'll observe 2 by 3 minus 1 by 3 is a 1 by 3, so 4a square, that is 16a square by 3 is the answer. If anyone have a doubt, yes, you can ask. Is there any doubt? So only 2-3 examples we are going to see here for the area, because it's one of the simple article. Already you know how to evaluate double integral. The new thing is here, that is only the formula, that is a double integral dx dy is a area. Okay, nothing than that.
Sir, don't erase this 1 second.
Pardon?
Don't erase this 1 second. I'm noting it down.
Little louder.
Sir, I'm noting it down, so just give me a minute. Don't erase it, please.
No. Okay. You note it. Note down it. No issue. Once you complete, tell me so that we can move to the next example.
Done, sir.
Done. Okay, good.
Thank you, sir.
So, a second example. This is a solved example. You got the answer. You can see the PPT. Only they're not drawn here complete curve. Okay, in the textbook it is not drawn a complete curve. The curves are incomplete. So this the one of the parabola should be like this. It's go from here to this side, and other parabola will go like this. This is the entire parabola, but we are not interested in the entire. So the required, yes, even though you draw the required only this part, that is also correct. So diagram you can draw this much or complete, both are the correct there. So the next question is here. Find the area of a plate in the form of a quadrant of an ellipse. Find the area of a plate in the form of a quadrant of an ellipse. Yes, what is the formula for area? (141).
Sir, can we take in polar or Cartesian?
So you should tell me which one.
So in polar it will be r
It is
dr
better.
d theta.
Not r
Yes,
dr
sir.
d theta now. You are not correct. First I will write a formula in Cartesian, say dx dy.
Okay.
What is the value of dx dy for
The ABR,
Sorry, sir.
ABR dr d theta.
a b r dr d theta? This is the correct formula now, because we are not using a simple transformation. We are going to use x equal to ar cos theta and y is equal to br sin theta, because this is the ellipse. For ellipse we use a special transformation of ellipse. Okay, and that time the value of dx dy is this much. 142, can you tell me the limits? Limit of r and theta? 142, 143, yes, okay, 170, thank you. Start.
Sir, 0 to 1, R is equal to 0 to 1,
Okay, and theta?
0 to pi by 2.
0 to pi by 2. Good, because it is written quadrant of a ellipse. So quadrant of ellipse will map to the quadrant of a circle. You can take any of the quadrant, but simplest is the first quadrant. So this r is equal to 1. This is the strip, r equal to 0, theta 0 to pi by 2. That's one good. Now the integration is so simple. AB is a constant, r square by 2. Limit of r is a 0 to 1. D theta is a theta 0 to pi by 2. And the answer we get as a pi AB upon 4. So obviously the area of, what is the area of entire ellipse? 148. Pi AB is the area of the entire ellipse, and the question is for the quadrant of the ellipse. So answer is the pi AB upon 4. Okay, pi AB upon 4 is the answer for quadrant. If A is equal to B, you get pi A square is the area of a circle. Okay, any doubt, anyone? Because of this, that special transformation, x equal to ar cos theta, y equal to br sin theta, the ellipse is converted to the circle of radius 1, r is equal to 1. Once you complete, tell me, so that we can move to the one more example there. No doubt? Can we move to the next question then?
Yes, sir.
Okay.
Yes, sir.
This is again a solved example. In the book, they're done in Cartesian form. The formula is not written directly, the answer is written. Actually, you should use that formula. Which formula will require here? Anyone? Root of a square minus x square. What is the integration?
So x by
So
2.
x by 2
X by 2
root over a
of
square
a square minus x square plus a square by 2 sine inverse of x
inverse
upon
x by.
correct. So that is a formula you'll require if you want to do it
Yes,
in
sir.
Cartesian form. Otherwise, yes, whatever we done in polar, that is also the correct. So the third question is on the screen now. Find the area lying inside a cardioid and outside the circle r is equal to a. Inside the cardioid, r is equal to a1 plus cos theta, and outside the circle, r is equal to a. Obviously, now we are not drawing the Cartesian plane. Everything is in a polar. So this is known as the initial line. This is known as the initial line, that is theta equal to 0. That is x-axis. X-axis is the initial line, theta equal to 0. We have to draw this cardioid r equal to a 1 plus cos theta 151. Which type of this cardioid? Okay, 154. Yes, tell me.
So this is a right hand side cardioid.
Correct, very good. So good. This one is a right hand cardioid.
Yes, sir.
Yes, cardioid will go like this. So what is coordinates of this point?
So just a second.
Okay, and what about this?
0, comma a.
So,
Oh, sorry. Yeah.
Okay, we are in polar now. We are in polar
yes, sir.
that way. And this is actually 0 comma pi, but we are not required right now. So another curve is there, that is r is equal to a. R is equal to a is a circle with center 0 0 radius a. So this will be a radius. This is in between half. So the circle. So this one is r is equal to a. Okay, and the region is outside the circle and inside a cardioid. So obviously the region of integration is this one. I hope it's clear. The position of a strip along radial. Now let I ask 159, 159 or 158. Yes.
Yes, sir.
Tell me the limits of R.
Sir, limits of R.
Where it enters in the region, at which curve?
Sir, it's a
Strip
point.
enters in the region at R is equal to,
A to 2A.
not correct. Yes, 157. 157. 157. You're not audible.
Yes, sir. Yes, sir. Yes, sir.
Tell me.
So it's so A to 2, even I think so.
Not correct. Not correct. Okay, I think 141.
Yes, sir. A to a 1 plus cos theta.
Correct. So when the strip touches to the curve, first r equal to a, and later on it touches to the curve r is equal to a 1 plus cos theta. This way we get a limits in a variable limits first. So we say here the area is a double integration a to a1 plus cos theta, and obviously it is r dr d theta because we are doing in a polar form. What about the limits of theta?
0 to pi by 2.
0 to pi by 2. Is it correct? Because the region is not.
Sir,
Sir,
3 pi by 2 to pi by 2.
0 to pi by 2.
We have to multiply it by
It's
2.
3 pi by 2.
3 pi by 2.
2 to pi by 2.
Sir, it is symmetric, so we will take two
Yes.
times of.
one by one only. You will observe the region is symmetric, and by the symmetry we can take it as a 2 times 0 to pi by 2. Whatever the region exists in the first quadrant, exactly same area there in fourth quadrant, so we take a 2 times 0 to pi by 2. Okay, clear?
Sir,
Yes.
so instead of twicing the integration, we can also take pi only 180 degree it is turning.
No, because if you take 0 to pi, na, you are saying 0 to pi, na?
Yes, sir. 0
Then
to
you are not
180.
getting that area. You will get totally wrong answer, because only up to here these limits will exist. After that, it is not taking the same limits there.
Okay, okay, sir.
So you may get this area there, this area later on, minus.
Okay, sir.
But I didn't understand why you took two constants.
No, we are taking 2 because this shaded area which exists in the first quadrant, the same area exists in the fourth quadrant there. Are you getting?
Yes, sir. Thank you.
Okay. So we can use a symmetry in the calculation. We can say it is a 2 times whatever. So here the region exists in the first and fourth quadrant exactly same. So 2 times there. So this 2 will be as it is, or you can integrate simultaneously because it's multiplication. Integration of RDR. No, you cannot do simultaneously because inner limits are variable, not constants. 0 to pi by 2 as it is. It's r square by 2. A times 1 plus cos theta. And this 2 gets cancelled. Okay. Now this integral 0 to pi by 2. A square 1 plus cos theta bracket square minus a square d theta. Any doubt up to here? Okay, the next step is again straightforward. It's a 0 to pi by 2. This a square is common throughout. This 1, we are squaring the bracket, 2 cos theta plus cos square theta minus 1 and then d theta. We'll observe again this 1 gets cancelled. Is there any doubt? So one last step is left now, integration. So this a square as it is. A square is as it is. Yes, anyone? Tell me the integration now.
2 sine theta.
That Wallis formula.
2 sine theta is
2
correct.
sine theta.
Sine theta plus, so we will write cos by theta as 1 plus cos 2 theta by 2.
Correct. 1 plus cos 2 theta upon 2, and then you have to integrate. That is one of the way. The simplest way is Wallis formula. Someone said already. Can anyone tell me the Wallis formula? So for 2 sine theta, for this integration, the limit is a 0 to pi by 2 plus Wallis formula now. Cos, because limit 0 to pi by 2 cos square theta d theta. Answer is, what is the integration of cos square theta by Wallis formula?
One by 4.
Yes, not 1 by 4 only. It is actually starting
5 by 4.
Sine 2 to theta by 4.
Pi by 4 is the answer. You will start with n minus 1.
Yes,
So
sir,
n
pi
is
by
2
4, pi
here.
by 4.
So this 1 by 2 into pi by 2 because even power is there, and that about the end of the integration. Now, if you observe here, if you put upper limit, sine pi by 2 is a 0. Sine pi by 2 is 1, my mistake, and sine 0 is a 0. So this is the last answer. We get it as a square will be as it is there, that a square. So sine pi by 2 is 1, so that is 2 into 1, but sine 0 is 0 plus pi by 4. So this is the final answer. Final answer is a square in bracket pi by 4 plus 2, or a square by 4. If you take 4 as a common, pi plus 8. So that about the area between the circle and cardioid. A square by 4 into pi by 8 square unit. Any doubt?